Alright, so today we're going to talk about key features of exponential functions. We're going to talk about the intercepts, the intervals, or the positive, negative, decreasing, and the end behavior. Okay, x-intercepts on an exponential function. Well, you're either going to have none, because they don't touch the x-axis, or they will only have one. Okay, and that only happens if there's a transformation of some kind. And there has to be some type of transformation or shift of the points for that to happen. Okay, for y-intercepts, always, okay, they will always only have one y-intercept. Okay, always have one. Okay. Exponential functions are increasing means they're going up from left to right, or decreasing means they're going down. Okay, you have two types. This side's going to be increasing, and this side's going to be decreasing. Okay, so let's do the increasing first. Okay, the first one would be something like this. Okay, it's going up from left to right. Or it can look something like this. Okay, still going up from left to right, just in a different way. Okay, for decreasing, it's going to look something more like this. Okay, or okay, it's going to look something like this. Okay, so those are our four types of graphs for exponentials that we have. Okay, let's do an example. Okay, we're going to be using the function 1/2 to the x power. Okay. Does it have an x-intercept? The answer would be, in this case, it does not have one because there is no k value. Okay, for it to have an x-intercept, there has to be some type of k value. Okay, of some kind for it to work. Yeah, it needs to have k value. For the y-intercept, easy. If I put in 0 for x, remember, anything to the 0 power is 1, so my y-intercept is 0, 1. Okay. In this case, remember when we're talking about this, because it's a fraction here as our thing, this is going to be going like this. Any fractions would always look like that if your base is a fraction. So in this case, notice it is never increasing, so we don't have an increasing variable. It's always going down from left to right. Okay, so because of that, it's going to be decreasing from negative infinity to infinity. Okay. Positive intervals. When are the y's positive? Well, the y's are always going to be positive in this case. So that's from negative infinity to infinity. Remember when you're talking about intervals, although you're looking at the y values, you're actually talking about the x values. Okay, when you're writing it. Okay. Since the y's never appear in the negative because of our asymptote of y equals 0, it's never going to cross that point. We don't have any negative interval here. Okay. And for our end behavior, remember our end behavior we write like this: as x approaches infinity, y approaches blank. And as x approaches negative infinity, y approaches blank. So let me sketch the graph again real fast. Here's the graph. And as we go this way, as x gets more negative, the y is going this way, which means it's actually approaching positive infinity. Okay. As I go this way, though, remember we have this asymptote that we're never going to cross. So instead of y approaching negative infinity, it's slowly approaching the number 0. Okay, and that's your first idea of what a limit will look like. Alright, on the next example, we're just going to come up with some equations that fit our needs or our stipulations. So the first one is no x-intercept, and remember, if it doesn't have a k value, it won't have an x-intercept. So you can make up any function. Let's just say 6 to the x. Okay, there is no k value back here, so that will not have an x-intercept. Okay, never cross the x-axis. Okay, a y-intercept at negative 3. So let's just imagine, here's my function. Okay, let's just say it's 6 to the x for what we're talking about. This point is at 0, 1. And I need it to be down here at 0, negative 3. Well, how many do I need to move it down? I can move down 1, 2, 3, 4 units. Okay, and since we're going to go down, we're going to subtract 4. So it's going to be 6 to the x minus 4. Okay, because we're trying to move it, we need to shift that point down. Okay, if I want it to be decreasing over time, or we talked about it, that means our b, we're going to get to ab to the x. Our b has to be a fraction of some kind, so I'm just going to make it, let's say it's 1 over 5 to the x. Okay, that fraction right here will guarantee that they will be decreasing over the entire time. Okay. Alright, so on this one, we need a positive interval over 2. So let's just take a positive increasing function graph. Let's just say it's 3 to the x. Or let's just say it's 2 to the x to be fair. Okay. This point here is at 0, 1. I need to move that point to here to be at 2, 0, because it needs to be, I think that 2 from there. Okay, so I need to take this point and move it down 1 unit. Okay, well that's my k, so I know it's going to be minus 2 at some point. Then I know it needs to move right 2 units. Well, I know that's going to be my exponent from our transformations that we talked about yesterday. So let's do 2 to the x minus 2. Okay, 2 to the x minus 2. Okay, 2 to the x, then reverse transformation. Okay, same thing with the next one. We have a graph here. Okay, let's just say again it's 2 to the x. Okay, we have this point that's at 0, 1, and I need to move it to 3, 0. Okay, well, I need to move it down. To get it to 3, 0, I need to move it down 1 unit. Okay, and then I need to move it right 3 units. Okay, well, down 1 unit would be minus 1. Right 3 would be minus 3. And it goes to 2 to the x. So that's what x is equal to 2 to the x minus 3 minus 1. Okay? As x approaches negative infinity, y approaches infinity. So x goes this way, y goes this way. That's a decreasing function. Follow your arrow. So anything with a fraction in there as a base will work. Okay. Exponential functions have one x-intercept. That sometimes happens depending on if it's transformed. Exponential functions will always have one y-intercept, always. Okay. Exponential functions are increasing. Sometimes, that sometimes happens. Exponential functions have positive intervals from negative infinity to infinity. Again, sometimes happening. That's if they're an increasing function that don't cross the y-axis. Okay, they have symmetry. That never happens. They're never symmetrical in any way. And as x approaches infinity, y approaches negative infinity, that's sometimes.